Hi, I'm Dustin. In this video, I'm going to show you how to create a basic simple program that uses a GLS ODT C-CN occupancy sensor to trigger lights on and off. To save time, I've pre-built this program. I have an MC4, a couple dimmers. One of them is dimmable loads, the other is switched. I've put in a basic CNX B4. That's a pretty old keypad that just has four buttons. And then I've also got the sensor. This is what we care about, the GLS ODT C-CN. What I want to start looking at is the outputs of this sensor. So the ones that we really care about are room occupied and room vacant. Those are the only two that we're actually using in this program. I've got a commented out room occupancy feedback that we can watch in Debugger, and that can help you with troubleshooting. I've also got force occupied, force vacant, and enable raw states. And that will just give us some troubleshooting options. Now, I should mention, I don't have an actual sensor here with me to demonstrate how it works, but I'm just going to explain how you integrate it in the program. There's other things here that we don't really care about for right now. The sensor IR, I don't care about that. The sensor configuration, there is, I believe, a remote control that you can order for the sensor to adjust sensitivity, or you could set some signals in here that you can trigger in Debugger, and it will save the state of whatever you set it to last. It even stays if there's power reset or something like that. So you can use this increase PIR, increase ultrasonic. So US is ultrasonic, PIR is, I think, proximity IR. So there's two types of sensors built into this device. We're not going to do anything with that right now. A lot of times the default settings will work out of the box, and it's just a matter of placing the sensor where it's going to pick things up properly. But if you need to disable the ultrasonic or the IR, you can do that and stuff in here. One thing you should know about this occupancy sensor, this timeout value, it allows you, if you feed it from simple here, you can have a dynamic timeout so you can change how long it waits. And this is basically the time from when it detects that a room is occupied before it sends a signal that it's occupied, and the same thing when you exit the room. Now, the default value, if you set it to 0 or you don't connect it, the sensor will use the timeout value that's set from the IR remote. And if you don't have the IR remote, then it's whatever the default for this device is. I also want to draw your attention to grace occupancy, this output here. We're not using it in this program. So you could use that in a case where if somebody comes back into a room, you want to turn the lights on if they run back in. I don't usually use that, but that's something that you could play around with as well. So now going to my actual loads. So I've got a pretty basic dimmer with 4 analog levels in. We don't care about the analog levels out in this program. And all this other stuff we don't care about. We're just setting it 4 analog levels. This other device here is basically 8 switched loads, so we can tell each one to turn on or turn off. And I've just got these commented out so we can watch them in Debugger if we want to troubleshoot it. On the keypad, I've kept it very simple. I've got button 1 as lights on, button 2 as lights off. And the feedback, I just looped that around. If you press F3, you can see that it's looped from input to output, and that just gives you the light up when you press it. In this case, I'm not going to track the states. So in the logic here, the first thing I'm doing, the output of this device, this room occupied is always going to be high unless it's vacant, in which case it's going to always be vacant. We don't want that to interfere with some of the other stuff that we're doing in our logic, so we can't use these signals directly. We're running them into a multiple one-shot with 0.1 pulse. So I've got a room occupied pulse and a room vacant pulse. Now, it's always a good idea if you're using signals that are pulsed to indicate that somewhere in the signal name, just so you know. And the next step, we're running it into an OR gate, and it's basically a condition of things that could possibly turn the lights on. Now, if I had connected this room occupied feedback directly, then it would jam this OR gate, and the keypad pressing lights on wouldn't work. And you want the keypad to be able to change states as well. So I've basically OR'd the occupancy sensor saying that the room is occupied, or pressing the keypad lights on. I've done something similar for lights off, where you can press on the keypad for lights off, or the sensor determining that the room is vacant will trigger the lights to turn off. Moving on with our logic, we've got a condition to turn the lights on with the keypad press or when the room is occupied. And we've got a condition to turn the lights off if the keypad is pressed off or if the room is vacant. Now these two pulses, I'm going to use them to do stuff. So I've got basically a button presser, which is one press in will trigger a bunch of presses out. That's going to control my switched loads. So I've got switch load 1 on, 2 through 8. Tells them all to turn on. Now if you remember in this device here, it's going to be the on for all of these. I've got a similar thing for off, where the off condition pulse will switch all those loads off. That deals with the switch loads. Now the analog levels here, we're going to use analog preset. And what analog preset does is a digital input pulse will make a certain number of analogs. Now you can expand, so you can control a bunch of them with Alt+. It'll set them all to the level that you specify in the ramp time of this. So when this goes high, within 3 seconds, the lights will raise to 100%. We have another preset for lights off condition pulse that sets them all to 0 in 3 seconds. Or maybe you want to have the off time fade off slowly. So that's basically this whole program. I'm just going to demonstrate it here. I'm going to load this to my processor and run Debugger. So now I have my program loaded and I'm looking at Debugger. Now, since I don't have the actual sensor, we don't get that feedback of is it occupied or is it not. So I'm going to have to simulate these signals. So let's say room vacant. So what happens is we get that pulse and then lights off condition pulse. All these levels were already at 0, so we don't see the fade. And then we see the pulses to turn them all off. If I say it's not vacant anymore, it's going to be occupied. Now we see some stuff happening with those fades. So this is my occupied pulse coming from that one shot. And these start at 0 and they start ramping up. The switch lights go on right away, but you see these start to ramp up and they're all going up and they'll sit at basically 100%. If you want to see that as a percentage, you could change the signal display format to percentage. And you'd have to do that for all of them unless you change the default analog format to percent. So then all the analogs will show that. Now if we do the room vacant again, we'll see that 15-second. It takes a lot longer for it to go down. The other thing I should show you is if we hit the keypad. So we turn them on. They're off right now. Turn them on and they'll hit that same condition. So they're going to do the ramp. And they can go on and off independent of what the sensor is doing. The other thing that is important to mention is these commented out force occupied and force vacant. This can be really helpful when you're testing your logic because you don't have to wait for the sensor to detect another state and pass that grace occupancy time. It'll basically switch the outputs here immediately so that you can see how it responds. Hopefully that video was useful. If you like this channel, please subscribe so you can get notifications when we post new content. Please like the video, leave me some comments, let me know what you'd like to see. We've got some really cool stuff planned and looking forward to really supporting the Crestron programming community with overworked logic. Thanks.